Hello everyone, welcome back. In the previous video, we've already covered what MCP is and why it matters. So the concept is enough. Let's actually build something with it today. In this section, we are going to create a simple MCP server and client in Python. Our little demo server will have a tool which is calculator. This will give us a hands-on look at how the pieces come together. First, let's set up a server using the Python MCP SDK. We are going to start with the simplest transport stdio. This means our server will communicate with the client using standard input and output. This is nice and simple for demos and testing. There are several ways to set up an MCP stdio server, but we will use the first MCP class because it's the simplest for beginners. So let's take a look at the code. Open the code editor. And first of all, you have to set up your Python environment. To set up Python, nowadays the UV Python package is really popular these days, so I recommend you to install the UV Python package. How you can install the UV Python package? You can go to the official documents and you can see whether your OS is macOS or Linux, and if your OS is Windows, then you can follow these steps. But don't worry, if you are familiar with using pip Python package, then you can also install this command, and after that you can check whether you installed the UV Python package properly or not. Then you can check this UV version and you can create a virtual environment like this. We can initiate the Python environment. You can check the Python version now. The Python version is now 3.13. If you want to change your Python version, then delete all the files and also delete this virtual environment folder, and you can create by specifying the Python version. If you want, the Python version is now 3.11 and initiate again, then we can check our Python version is changed. And how we can install MCP Python package this way: copy and paste, then done. You install the Python MCP SDK, and we can check by activating the virtual environment. For example, source band bin activate. Then you can run Python interpreter and import MCP. Now we have to set up an MCP stdio server with first MCP class. Let's make some directories: stdio server .py, and write the code for import fast MCP, and MCP equals fast MCP, and name is calculator. You can run with a UV command, which is UV run and your script path servers / stdio server.py. Yeah, you can see a hello world is printed, and the first MCP object is also printed. So we have to define some tools. How to define MCP tool is really simple. You can just create a Python function as you did before, like this: add a and b, which is just return a plus b. It's very simple, and all you have to do is just MCP tool. All you have to do is just add a decorating of MCP.tool. So I inserted some basic calculation functions: add function, subtract, and divide, and multiply. And I also specify the error case if b equals 0. And it's pretty simple. We registered 4 truths, and each one just takes in numbers and returns the result. Here are some important tips when creating truths. First one, specify input and output types. Python doesn't require type hint, but since these tools are used by LLMs, specifying types help the model understand what to send. For example, if you don't indicate that add expect integers, the LLM might provide a string instead. That could lead to unexpected results, which we want to avoid. And second, add a clear comment or docstring explaining the tool. Just like when you ask ChatGPT something, it helps to describe in detail what the tool does and why it exists. These comments are fed to the LLM so it can easily understand when and how to use the function. Here are some tips for comments. Write comprehensive tool descriptions, provide detailed parameter documentations, include usage examples in docstrings. And third, handle errors gracefully. Just like humans, an LLM can correct each mistake if it understands the error. Clear error message help the LLM identify and fix issues. For example, database connection errors, division by zero, or API key error. And fourth, choose descriptive names. Naming is important. A clear, meaningful name helps both you and the LLM understand the purpose of the tool. Now the server setting is done. If you want to run this server, then you have to mcp.run, then the server will activate it. You can check by executing this script. You can see any other print statement, but it actually activate the server. So now that our server is running, let's see how we can actually call these tools from a Python client. First, let's set up the MCP server for stdio MCP server. Here is we are creating stdio server parameters to tell Python how to start our server. Command is the command you'd normally run in the terminal to start the server. Args or any additional arguments needed to your server script. Once we have the server parameters set up, we can connect to the server asynchronously using stdio client. This is useful if you want non-blocking calls and better integration with the other async code. Here is what's happening step by step. stdio client connects to our running MCP server using stdio, and client session creates a session for sending requests and receiving responses, and session initializes set up the session so it's ready to call tools. From here, you can start calling any of your registered tools through this session. Alright, let's create our stdio client. First, we'll make the client directory and make the stdio client.py, and we have to import stdio server parameters, and server params is stdio server params, and command is ub, and argument is run servers and calculator. Actually stdio server. Yeah, we define async define run, and with this context manager server params as read and write, client session as session. And we also have to import this client session and initialize session, initialize, and if name equals main, then actually the function is defined as async, so we have to import async IO, and with async IO phone with a sync IO, and in this way we can create stdio client which connects to our stdio server. Stdio client. Actually, I also forgot to import this stdio client, so we can run this using uv run client stdio client.py. Then the error doesn't happen. We now connected to our stdio server, so you can check with functions. This is actually the request tools list request to our MCP server. You can see the method is a tools list, and our client request to our MCP server, and it will give the result. Now we can check by iterating tools. Alright, so let's check. We iterate these tools using tools, and each tool has name, description, input schema, and output schema, and title. Alright, let's check. We will run client stdio client. Then we can check the tool name is add, and the description is not specified yet. And so if we change the tool more detailed version, and let's run again our client source code, then we can check our add function, and the description is this docstring. This comments is inserted, and our input schema is A is type integer and B is type integer, and we have to specify A and B. If B is not inserted in the function argument, then this will raise the error, and the output schema is also type is integer. So in this way we can communicate with the server. Alright, so we set up our client. Now let's check which tools are available on the server and inspect their details. Our await session list tools fetch all the tools registered on the server, as we already saw before. We look through each tool and print out each name, description, input schema, and title. This is really helpful for understanding what each tool does. And finally, we can call the add tool asynchronously using session call tool and print the result. We can check this how to call the tool. Result is await session call tool at A is 5 and B is 3. The call tool method is basically like this. You first specify the tool name, and you have to specify the argument in the dictionary type, and the other one is optional. And if the argument is none, then you can also don't have to insert arguments. And the internal method is also request tools call method to our MCP server, and we can get the result, and we can check by print this result. So I commented this out for this check tool calling. You will run client stdio client. Then the result is like this. Add result is meta is equals none, and content is blah blah, and the result is 8. The function is executed correctly. Alright, so we can call the tool, and we can know which tools exist in our MCP server. But you might be wondering, how can we set up an MCP HTTP server? So we can call the tools not just locally but from the internet. Let's take a look at streamable HTTP server. First, it's very similar. We instantiate the first MCP class and define our tools. And the main difference is how we call the run method. By default, first MCP run uses the stdio transport, which is why we didn't need to specify it before. But if we want to use a streamable HTTP, we simply pass transport equals streamable HTTP string. This allows clients to connect over HTTP and interact with our tools from anywhere. Let's create our streamable HTTP MCP server. First of all, let's make the file, which is streamable HTTP server.py, and also we have to import first the MCP class, and MCP equals first MCP server. And we have to define our tool. In this scenario, I will just write a simple return hello world style function. MCP run. The most important thing is we have to specify the streamable HTTP as a transport argument, and also we have to define this function as a tool. We can run this HTTP server using uvrun, actually type error. Then you can see our MCP server is activated on our localhost, and the port is 8000. Next, we can call tools on the MCP HTTP server from the MCP client. Since the transport has changed from stdio to HTTP, so the client setup should be slightly different. The main difference compared to the stdio client are we no longer need to instantiate stdio server parameters. Instead, we specify the URL of the server in streamable HTTP client. Since our tools are running on the local server, we need to specify the URL as a localhost. By default, the server runs on port 8000 and the endpoint is /mcp. Everything else works the same way as with the stdio client. This makes it easy to call your MCP tools over the internet without changing how the tools themselves are defined. Alright, so let's create our HTTP client. I will make in the client directory and name it HTTP client file. We define main function with async with streamable HTTP client. Actually, we have to import first. Import async IO, and from MCP we have to import client session and mcp.client streamable HTTP import streamable HTTP client, and our URL is localhost and the point is MCP as read string and write string. So async with client session and read string, write string as session. Await session initialize. Actually, you don't have to worry about too much this code, how to code like this. It's just a standard method when you need streamable HTTP client. So in this way, finally, we have to execute our session with async IO main. And we can run our HTTP client, uvrun client and HTTP client py. We have to execute our streamable HTTP server first. to open another terminal and specify how to execute your HTTP server. In this case, you will run servers and streamable HTTP server. Then server is executed now. You can see our server is running on HTTP now localhost 8000. With another terminal, we have to. So you can see our HTTP MCP server is executed and our client connects to our HTTP server correctly. Before ending this, if you're not familiar with how to go to your library code, I will let you know how to do that. If you use VS Code, you can select the class or function like this and click the F12. Then you will step into the function or class into the library. So in this case, from our HTTP client, you can see the internal method, internal logic, and which arguments are needed. In this case, the URL is needed for streamable HTTP client, and the others all optional. If you're not using VS Code, then we created the virtual environment. Then you will know there is a .vmb directory, and you can open up, and there is a library directory, and you can open it. And these are all the library you installed, and you can see there is a MCP. This is our MCP library. You can go to the file you want to know. So that's it. You've just built your first MCP server in Python. We created a calculator in our stdio server. We created a simple function in our HTTP MCP server. What we learned is how to set up stdio MCP server, and how to set up stdio MCP client, and how to communicate between MCP server and MCP client. Also how to set up streamable HTTP MCP server or client. So in the next session, we will take this further and look at how to build richer functionality by connecting to existing MCP server. So hope to see you again. Bye.